Good afternoon, students. Now we will study about the what is intensity of the electric field. Previous lecture we have studied about what is electric field. Electric field means it is the electric stress produced by the charge surrounding it. Now what is intensity of the electric field? Suppose if this is your charge, okay, this charge will produce electric field surrounding it, and if I place a test charge here Q naught, then this test charge will experience the electrostatic force. Okay, this test charge will experience the electrostatic force, and this electrostatic force divided by test charge will gives you the intensity of the electric field. Okay, so what is intensity of the electric field? The intensity of the electric field at a point is expressed in magnitude and direction, as in direction in terms of magnitude and in terms of direction. The direction of the force and direction of the electric field both are in same direction. It is the force per unit charge experienced by any charge by a test charge. Okay, so what is electric field? Electric field is equals to force experienced by the test charge divided by charge of the test charge Q naught. Then so how will you write the equation for the electric field? Electric field is equal to the electrostatic force between the source charge. This is your source charge, okay, and this is your source charge. And what is Q naught? Q naught is your test charge. Q naught is your test charge. What is test charge? Test charge is a very small quantity of charge which is very small in magnitude. Why it is very small in magnitude? This charge have the value very small, so that it will not disturb the electric field produced by the charge Q. So that's why it is known as your test charge. Okay, so what is electric field? Electric field is equals to force experienced by the test charge and the source charge divided by your test charge. But value of test charge is very small, so in terms of limit you can write this equation is also electric field is equals to limit Q test charge tends to very small, means 0, force divided by Q naught. So similarly, what is electric field? Electric field is intensity of the electric field. Intensity of the electric field means the force experienced by the test charge when it is placed in the electric field of the source charge divided by your test charge. Okay, so this is about your electric field intensity. And what is meant by test charge? Test charge means the charge which is having very small value, so that it will not disturb the electric field produced by the charge Q. And what is the expression for electric field? Force, electrostatic force between two charges, source charge and test charge divided by your test charge Q naught. Now this is about your electric field. Now we will study that how will you write the expression for electric field? Electric field due to the electric field due to point charge. Electric field due to the point charge. Okay. Suppose this one are your two axes. Suppose this is your x-axis and y-axis, and suppose this is the position of your charge Q. Q is what? Which charge? This is your source charge. And suppose I have to place a test charge at point this. This is the Q naught. Q naught is your which charge? It is your test charge. Okay. So if I have to find out the position of source charge Q, then I can say that this R vector is the position vector of the source charge, and this small r vector, this is the position vector for your which charge? Test charge. Now this gives you the direction between the force between source charge and test charge. This position vector you can write capital R vector minus small r vector. Okay. Now what is the force between two charges? Force between the source charge and test charge. Force is equals to, if these two charges are placed in the free space, okay, then 1 upon 4 pi epsilon naught if the charges are in free space space having the permittivity epsilon. Okay, 1 upon, what is the force? 1 upon 4 pi epsilon naught. What is the first charge? Q. What is the second charge? Q naught divided by, now we have to write this equation in terms of position vector. So I can write this equation, capital R vector minus small r vector, their magnitude Q into capital R vector minus small r vector. So this gives you the force between two charges. Now how will you define the electric field? So electric field is given by E vector is equals to the electrostatic force divided by test charge. If you substitute the value of electrostatic force, you will get 1 upon 4 pi epsilon naught Q into Q naught divided by capital R vector minus small r vector Q, magnitude Q, into capital R vector minus small r vector, this quantity divided by test charge. See this test charge will get cancel and you will get the expression for the electric field. Now what is the expression for the electric field? The expression for the electric field will be E vector is equals to the, what is the equation? 1 upon 4 pi epsilon naught Q divided by, this Q naught will get cancelled, Q divided by R vector minus small r vector, their magnitude Q, into, what is vector here? R vector minus small r vector. So this gives you the electric field for the charge, due to this charge, source charge, on which charge? Test charge, which is at a distance of r vector minus small r vector, and capital R is the position vector of charge Q and small r is the position vector of the test charge. Okay, this is your which axis? X axis, and this is your y axis, and this one is your source charge and this one is your test charge. So this expression gives you the electric field due to the point charge. And what is the direction of the electric field? Electric field direction is along the direction of the position vector r vector minus r vector, and this direction is the direction of the force, and direction of the force and direction of the electric field both are same. Okay, suppose if you place your source charge at the origin, if source charge, okay, if source charge is at origin, origin means center of the axis. Okay, if I place this test charge to the origin, okay, what happens? If it is placed at the origin, this r vector will be 0. It will come to this point. So if source charge is at origin, this capital R vector is 0, and you can write the equation for the electric field is equals to 1 upon 4 pi epsilon naught Q divided by, here we have to substitute capital R is equals to 0, then you will get R cube. It is not in terms of vector, here it is in terms of magnitude, that's I have written only R cube, and here capital R is equals to 0, that will give you the R vector. Okay, so this is the electric field when source charge is placed at the center of the origin. Okay, this equation you can write, this equation of electric field E is equals to the 1 upon 4 pi epsilon naught Q divided by, here observe that how I can write this equation. Here I substitute R square, here I take an R square into R is R cube, and here I will take the R vector. But what is the value of R vector divided by R? So R unit vector R vector is given as the R vector divided by magnitude of R vector. So magnitude means this, magnitude means only R, no need of there is a vector sign. So here substitute the unit vector. So what is electric field? E is equals to 1 upon 4 pi epsilon naught Q divided by R square into R cap. So this equation will give you the, this value is known as your magnitude of electric field. Okay, so magnitude of electric field. And what is the magnitude of unit vector? Magnitude of unit vector is 1. So what is the magnitude of electric field? 1 upon 4 pi epsilon naught q divided by r square. This will gives you the magnitude of electric field. This equation gives you the electric field in terms of point charge. And why this equation comes? When you substitute that if source charge is at origin and capital R is equals to 0, then this equation will get obtained. So generally this equation is very much important while solving the problems. What is the magnitude of electric field due to the charge q? 1 upon 4 pi epsilon naught q divided by r square. So what you learn is that what is electric field? Electric field means if there is a source charge q, this charge will produce the electric field surrounding it, and if you place any test charge close to that charge, then this force between these two charges divided by test charge. So test charge will get cancelled. So we will get 1 upon 4 pi epsilon naught source charge divided by r square. This will give you the electric field due to the point charge. And what is the unit of electric field? Force divided by charge. So what is the unit of force? Newton. What is the unit of charge? Coulomb. So electric field unit is Newton per Coulomb. And what is the direction of the electric field? Electric field direction and the electrostatic force direction, both are in same direction. Okay, thank you.